That makes sense. All right. So this is on. I'm talking to Mike. Why isn't echoing in class? Mm-hmm. Okay. So, Troy, at least you should be in a whole different classroom. So, unfortunately, guys, this is going to be a little funky because my tablet's dead. Because being on distance, this is going to be kind of tough to convey other than just dictating what I was going to write down. They're going to. Come on. Okay. So now, so we are here to talk about exams and the exam review. What would you like to ask? Go, Denise, go. Fall 2006, supplemental exam 1. Problem number 1. Okay, so problem number 1. Are we stuck? Okay, I said share the desktop. It's not sharing. That was weird. All right, so while Wimba tries to figure it out, we'll just read through the question. Problem number 1. What does the following program specified in file prg.c output? Note that the program is assumed to run on the onset, being compiled and linked with the compiler tools you have been using in the lab. However, it is assumed to be loaded at the address cc0200. Since you do not have access to the Aztec cross compiler, you cannot rebuild the pt8flb.c to actually load this program. Go ahead and show that to you. Here we go. To actually load this program at the address, in order to simply test the program, you must determine what the program will output from other means, since just because you cannot load and run the program does not mean that you cannot compile the program and examine the files that are output from the build tool. You may need to make some minor changes to a few of files other than the source file to get it to build properly. How does it determine that information? So you just got this C file right here that declares a global variable as a plus 10 and asks you to output that stuff. Okay, so because of the fact that we don't have mics in here, you're talking a whole lot, and I got to kind of catch up and repeat it before Troy, going online. Okay, so basically what you said is you took the P.C program, you ran it through the build chain and produced P.O, and then you ran that through an object dump, and you basically looked at what the thing looked like in assembly. And you saw a bunch of addresses, and were you just looking at the text section or the data section and the BSS as well in the object dump? Okay? All right. Why that instead of the map file? You can get a lot of places with the map file. Map file is your friend. Okay. So basically, all that this question is asking you to do is to repeat what you should have done with Lab 1 when I said, what does the program output and why? Okay? This question is not trivial. It's a pain in the rear. Okay? If you were the absolute ridiculous overachiever on Lab 1, and you could have gone through and you would have already done this. Because I asked the question in the lab, what does it take to change the load address? If you went through and did that and figured out what it took to change the load address instead of done a hypothetical thing, that's what this question is asking. Okay? So how would we adapt this question to be something that I would ask on the TS-7200? Okay, so basically what on the onset TT8, there wasn't a distinction between entry point and load address. On the TS-7200, we have to distinguish between the two. So I would have written this question a little bit differently and said, we want to load this program at the load address that's shifted a little bit, and let's just suppose that we want the entry point to be 100 hex bytes off of that. So you take the load address and add 100 hex bytes off of that. What do you need to do in order to change that? So basically what you would need to do is make the changes in the source files that you'd need to change, and you would answer this question by saying, okay, I made the changes that I needed to change. I built the program. I looked at the map file. I found what the address of A was from the map file, because you can look at a map file. Let me see if I can pull up a map file for P. Maybe we can coax Windows into working again. Full film. Okay, maybe we're in business. Last time I told it to share, it stopped at the frame that I told it to share at. It wouldn't, when I pulled up the exam and started reading it, it didn't show it up here. Okay. We'll just make sure I don't show you any answers from the exam. Nothing up this sleeve and nothing up that sleeve. You can find Lab 1. There is P.map. Okay. So P.map, if you recall, is this file that tells you what the linker went and did with itself. So all these things, it tells you what symbols it included from which files and why. Remember the P.C that we're using has two global variables, A and B. B is not initialized, A is initialized. So to make it look like what that exam question is asking, we're looking at the corresponding variable in here is B because it's not initialized. So what you should have discovered inside your lab exercise was that B gets declared down here in the BSS section. Uninitialized global variables are declared in the BSS section, which includes a bunch of stuff. And in particular, you've got BSS start is a symbol that gets defined. BSS end is a symbol that gets defined. And BSS start gets associated with this address here, which is the beginning of the BSS section. And then you've got BSS end is down here. That's defined at this address, which is the end of the BSS section. B is a symbol that is defined at that address. So B's value is whatever ends up getting assigned to it. We'll talk about that momentarily. B's address you can pull out of the map file. How do we determine what B's initial value is? Well, it's in the BSS section. And if you paid attention closely in Lab 2, when you dug through all of the source code and I made you get to CRT0.S, I've already got that pulled up in here. Oh. So, not this. Not that either. Rats. Forgot where the CRT0.S is. It's going to tell me about 100 of them. Anyway, in the CRT0.S file, there is a section in there that there's a section in the CRT0.S file inside the ARM where you're updating the ARM that it sets up a stack pointer and then it'll zero out the BSS section. So every variable that's inside the BSS section, it'll use a memset function and it'll zero out every variable that's in there. So after you load the BSS section, starting at the beginning of BSS start all the way through BSS end, it will write a 0 to all those memory locations. So B gets initialized to the value 0 by CRT0.S calling memset. So, if you look at the exam question, it says, what is this output and why? Change the load address. There we go. Okay, so it's printing %S. It's going to print this over and over again. It's going to say, what's the value of A? What's the address of A in hex? What's the address of main in hex? What's the name of the file? A, address of A, main. Main you can get from the map file. Address of A you can get from the map file. Value of A you have to say inside CRT0.S file, it got initialized to 0. It gets incremented by 10 every time. So it'll have an initial value of 10, then 20, then 30, then 40, and then 50. And then underscore file, that's the name of the file, and I told you this is trg.c. Okay, so all that remains are what are those addresses. So I would have to change in the build chain what I'm telling it the load address is. How do I change the load address? You got to go to the armelf.x file. Inside the armelf.x file, you tell it what's the initial point where I'm going to start linking. Okay, so inside here, right here inside the sections, you say what the initial address is that you're going to start building to. I say right here dot equals 0x00219.000. That tells me what is the address that I'm going to assume is the first point where I'm going to start linking stuff in. That equates to the load address. So you change that, you run your tool, you run it all through your compiler, and then your map file will tell you what address is everything at. Or alternatively, you build the map file and you assume that everything's at a 200 hex offset from what it was before. Simple question, but not so simple answer. Now, obviously, there's going to be some people who would know nothing about how to change the armelf.x file. I wouldn't expect you to go through and dig through that and have that answer. That would be not a really, really heavy error. I would have expected it to be, I would have been quite pleased if you would have gotten that, but at 10% of the, let's say that this problem was worth out of 50 points on a 200-point exam, That would have been like maybe 3 or 4 points, maybe 5 points out of the possible points on that question. It wouldn't have been, because that's, obviously, I didn't tell you about that. You would have had to discover that one on your own, and I wouldn't have penalized you really heavy for not knowing the unknown FedEx thing. If you wouldn't have known to use an app file, then I would have started beating on you severely. Okay, next question. Right. Okay, so the question is it safe to have a function return a pointer to a static local variable? First off, what's a local variable? Let's start off with the easy one. So you declare it as part of a function. It's just defined within the function. Okay? In the code that we showed earlier, is A a global variable or a local variable? Global variable. Okay? So you have a local variable. Its scope is limited to the function. All right? If it's static, what does applying the keyword static to a local variable do? So there is a phrase that I told you that I want you to remember when you think about static. Remember what it is? Local, global persistence, local scope, local scope, global persistence, whatever you want to call that. Okay, that's what I want you to think about when you hear the keyword static, because those terms apply to all the definitions of the keyword static. When you apply it to a local variable, when you say you want to have global persistence, you want it to be alive like a global variable, but you want it to have local scope. So that variable lives beyond the death of the function call. So you call the function, and it's just like you're accessing a global variable, but you can only access it within that body of the function. Can you take an address of a global variable? Can you take an address of a local variable? That's totally fine, just as long as the variable still is alive. So you can calculate and use its address, but as soon as the variable goes out of scope, you better not be trying to dereference the pointer. Okay? So the converse of the question, is it safe to return a pointer to a non-static local variable? No, it's not safe, because of the fact that the variable itself that you're taking the address of goes out of scope and is effectively deallocated. Is it safe to return the address of a static variable in a local function, or in a static local variable in a function? Then yeah, it is safe. Is it wise? What's the point of having it be a local variable if you're returning the address of it? So it's a debate. It's a matter of debate of whether or not you want to do that. Okay? Tony. All right. So raise your hand if you thought Lab 2 was easy. Printf. You're in the same boat as everybody else. Don't worry about it. It was hard. Awesome question. Awesome question. Anybody remember what exam I put that one in? Okay. That was question number 3, I think. An exam. All right. So this is the up. Okay. So here's the question. The following is the first line of code. This is in Fall 2007 Exam 1. So you have this line of code: underscore standard out underscore r parenthesis reent arrow underscore data equals underscore reent. This line of code contains several macro invocations, expand the macros, and provide below the C code output of the preprocessor corresponding to that statement. So there's 2 ways to answer this. You can either put in and be the human compiler and figure out what this is supposed to be, or you can ask your compiler and go and compile this statement, as long as you include the right set of header files. You can ask your compiler to output preprocessor output by using the -E option in your C flags. So if you take printf.c and you've got and you've told it where all the proper pound include statements are, and you compile that, it'll tell you, it'll output the source file that'll be your pre-processed but not compiled output. That's kind of overkill for this. You should have done this already. You should already know. And those of you who came and talked to me about Lab 2 in my office, this is where we started. Okay? Underscore standard out underscore R is a macro. Where is it defined? It's defined in stdio.h. It's defined as a macro that takes the parameter that it's given, dereferences it with an arrow, and accesses the underscore std out field. Let's see, how can I... This is where I pull up the tablet and write on it. And now we're seeing my email there. That's good. Okay. So. Switch over to this guy. Play tablet with him. I bet it is. Where's the pen? Where's the pen for the tablet? Ah. And where's the software to make it go? Starboard. Okay. We'll see if this goes. Well, I'm a bit disorganized, guys. Sorry, because this is out of my mode of what I'm doing. This is fall 2007 here. This should let me write straight on this. Okay, there we go. Underscore std out underscore r. That expands to x arrow underscore stdout. Okay, underscore reint. Anybody remember this guy? Underscore impure ptr. Okay, so if I expand this guy out, then I'm going to end up with impure ptr arrow underscore std out arrow underscore data equals underscore impure ptr. Okay? Well, that doesn't work so well when you, all right. Hope you got that down. It disappeared. We'll type it. Okay. It says, in what file is the stdout underscore r macro defined? That one's easy. That's in stdio.h. In what file is the macro underscore reint defined? this reint.h, not in reint.h. There's two reint.h's. But I would have forgiven you if you just said reint.h. Okay, where, in what file, what line of code is the pointer to the data structure which contains the underscore data field initialized? Holy cow, what does that line say? So there is a data structure that contains a field underscore data. What data structure is it? Well, it's the data structure that the underscore stdout pointer points to. Okay? It's not the structure that the impure pointer points to. It's the structure which the underscore, it's the structure that stdout points to. So you got to look up what all this pointer chain business is all about. Okay? So what file line of code is the pointer to the data structure which contains the data field initialized? Okay? So stdout points to a data structure of type underscore underscore s file. Where is that initialized? Checking it goes to, it calls underscore underscore s init, which calls underscore underscore std and passes underscore underscore sf plus 1, comma, something else, comma, underscore underscore swr, ORed with underscore underscore slbf. Hope you can regurgitate the printf code off the top of your head, comma, something else. Okay, so that is in, I can't remember what file that's in. But anyway, so this is a function call. This call, and I don't think it's got underscores in it, but that's at the top of the file it's in. It's like kind of p.c. But anyway, that function is in there, and that initializes the data structure that underscore stdout points to. And you'd have to find the name of the file and the file numbers. Okay, what file, what line of code is the data structure pointed to by the pointer from part C defined? I botched it. That's the answer to part D. So the answer to part C is the reint init macro in this int.h invoked in impure.c in the initialization of impure data. Okay, so in the reint init macro, this reint init macro expands to assigning to the first field of so it assigns to the underscore standard out field the address of the underscore underscore sf bracket 1. Okay. How and where is the data structure from part D initialized? Okay. Data structure from part, so E. Let me see if I'm getting this right. Where and what line of code is a pointer to the data structure which contains the data field initialized? I think I will. I'll take the grief on this for wording this question a bit poorly. But anyway, what I wanted you to do is I wanted you to tell me where is, and obviously if I can't decipher what I'm asking, I'm not going to expect you to. I've learned a little bit about asking test questions over a couple of years, so I think this is poorly worded. What I was after is that you told me where the file structure that stdout points to, where it gets declared, where it gets allocated, and where it gets initialized. So where it gets declared is it's part of the reint data structure. The pointer itself is part of the reint data structure. Where it gets allocated is it gets pointed to a structure that's inside the reint data structure, the underscore underscore sf array sub 1. Where that gets initialized is by the check init chain that calls down to the std function that passes the address, or passes underscore underscore sf plus 1, which is the same as the address of sf bracket 1. Okay? And so inside the std function, it just initializes all the various fields. So that's where, in particular, of particular importance to printf, it initializes the file data structures _write field to the _s_write function. So that was what you should have been able to track inside Lab 2. All right. Onward. Who's next? Or did this not make sense? Did I confuse the tar out of everybody here? Okay. What are we doing on time? We still got a few. Oh, and by the way, this was not a question that I expected you to be able to answer without having access to the source code. I didn't expect you to chew this out off the top of your head. Okay? Okay. There.
3 locations of variables can reside.
3 locations of variables can reside. Where is my variable? Where are local variables? On the stack. Where are heap variables? That's a hard one. On the heap. Where are global variables? Somewhere in global memory. Your data section or your BSS section. So stack, heap, global memory. Okay? Sometimes I ask gimmies. Sometimes. Levi, you're itching to ask something. I can tell. Okay? Is that the region one?
Yes. We're working together trying to figure out where to.
Okay, so problem number 1 says create a new loader which is capable of loading multi-region executable files. As in Lab 1, your loader consists of 2 parts, the host side loader and the target side. You must implement both sides of the loader. Clearly distinguish in your implementations which is host side and which is target side. Multi-region executable is a program which contains portions of code or data which must be loaded at different, potentially non-contiguous locations in the memory map. Each region has a certain length that is defined by the linker. Assume that you are provided with 2 files, prg.bin and prg.cfg. prg.bin file contains a concatenation of the binary code and data from each of the defined regions. Program.pfg file is an ASCII file which contains the entry point address, number of regions, and for each region a load address and total region size. Example program.config file is, here's a load address, here's the number of regions, or here's an entry point address, here's a number of regions, then you've got at 200,000 hex, that's the load address for the first region, 218 bytes there, load address for next region, number of bytes, load address for next region, number of bytes, and so forth. Okay? Feel free to modify the source code I provide for Lab 1. You don't need to implement compression. You don't need to implement a make file. You do not need to put the program.bin file into the FLD format if you don't want to. You just need to make sure your target side can accept the data in the format that the host side sends. So, all that you're doing is you're implementing 2 sides of the serial port. Okay? You don't need to reformat the data. You just need to send the data. So that would indicate to me it's most appropriate to put the implementation in FLD.c and in bootloader.c. Other questions about that or other stuff? Okay. That one shouldn't have been too terribly tough. What I saw on that problem when I graded exams from when they took it is a lot of people messed up. What was the code to access the serial port on the host? And what's the code to access the serial port on the target? So I saw a whole lot of serial reads and serial writes inside bootloader.c. For serial read and serial write, invoke a system call under Windows. Last time I checked TS7200, no worky under Windows. We could worry about putting Windows on there, but why do such a bad thing to such a good piece of hardware? Anyway, other questions? Okay. Like on the printf question, where I say implement, or is that a scanf? Anyway, Okay. So the question is, what's the refresher? What in the world are you talking about when you say blocking versus non-blocking? Implement interrupt-driven input using the timer interrupt. Okay, so basically I ask you to implement 3 functions: read line, check read, and read line block. Okay, so we're assuming that you've got a serial port that connects your host to your target. We want the target to be able to do, we don't want to, so like in Lab 3, Phase 1, you had to implement you had to use the FGetS function that I gave you that would access the serial port and get data from the serial port, and then allow your target side to parse that data that it gets. Well, we want the target to be able to grab data without having to sit there and wait for it to arrive all the time. The problem is whenever you have data coming in on your serial port, if you're not there paying attention to when it's there, multiple bytes could come in and overwrite each other. So we want to be able to say, I'm going to request data, I'm going to just offload this data writing to maybe like a concurrent thread or some other entity that it'll watch the serial port, wait for the data to arrive, and fill up a buffer. And I'm going to go do my computation in the meantime. Okay? So a blocking read is where I access the serial port and I say, wait for data to arrive, and don't return from that function call until the data has arrived or until some other parameter is met. Maybe I've got a timeout associated with it or something. A non-blocking read is where I issue a request to some parallel hardware or other executing entity, say, please do this for me, and then I go and do other things in the meantime, and I come back later and I say, is this read done yet? So that's what the check read does. So read line is where you say, I'm going to read, I want to request that a line of data be read in from the serial port. And so I call read line, and that issues a request, and then I go back and I do other work. And then later on, when I want to see if my read line has been satisfied, I'm going to call check read, and it'll tell me, yes, the read is done, or no, it's not done. There are some times where I want to wait for the data to arrive. So I want to send off a request, and then I want to wait here until it's done, because I don't want to have any lag in between the time where it actually finishes and where I realize that it's finished. So that's what the third function is, where it says read line block. And you basically just implement read line block as a call to read line and then a poll of check read. So you call read line once, and then you say while not check read, semicolon. Is thing. So how would one go about doing this, handing this read request off to somebody else? Who's the somebody else? You got another TF7200 board sitting over there? Spin off a thread. Do we know how to do that? Not yet. We have to use our interrupt. That's the only way we know about implementing concurrency. So what we're going to do is we're going to set up a timer interrupt that will periodically check the serial port. How often is data going to come down on the serial port? Well, let's suppose that the host is fire hosing data as fast as it can. What's the fastest rate at which the data can come and appear? Well, it's governed by the baud rate. So if you have, and this is something that's a little bit tricky, and I didn't hold people's feet to the fire too much about this, but I say that you've got a maximum baud rate of 2,000. What does baud rate mean? Well, baud rate says how many bits per second are you transmitting. If I've got 10 bits on the host side that I want to send, or let's say I've got 8 bits on the host that I want to send 1 byte down. How much time does it take? If I've got a baud rate of 2,000, that means I send 2,000 bits per second. But it takes 10 bits to communicate my 8 data bits, because I've got to send a start bit to 8 data bits and 1 stop bit. Okay? So in order to figure out the time that it takes to send 1 byte, you've got to factor in 10 total bits per 8 data bits, and then divide that into your baud rate, and that'll tell you a data rate. And so what you're going to do is you're going to set up your interrupt to run once every time a byte can arrive. And once you've set your timer interrupt to check every time a byte arrives, and you're going to go into your PIT interrupt, check to see if you're going to check the flag on the serial port. And how do you know what flag you're supposed to check? Well, you go and you look at the underscore read function that's in the ARM syscalls.c file to see how you access the serial port. And there's just a register in there that has a hardware flag that you query, and you see, is that flag set? And if the flag is set, then there's a byte available. If it's not set, then there's not a byte available. So every time you get into your interrupt, you check that flag to see if it's set. If it is, you read out the variable, you stuff it into a shared data structure, and then you exit. Otherwise, you just exit. So you set up your interrupt, and the rest of the problem just involves setting up that shared data structure where your shared data structure is effectively a pointer that readline allocates. You grab that guy, and you just put data into it until you get a 0. That one's a hard one. That one's involved. The region one, not so hard. That one was a doozy. Was that enough detail? No? Yes? I'm seeing a whole lot of very depressed looks in here. Okay. Other takers? I said I would be extremely available via email. Unfortunately, my cell phone just died. And that's my extreme availability, is I get my email on my phone. I'm going to have to fix this issue shortly. May or may not be available for all kinds of meetings on Thursday, but I will at least be accessible. Okay? We still got 3 more minutes. Come on, I make all use of all your time, so you ought to make all use of my time. Leslie, what about the RUSs? What are the usual size? I don't think they exist. Who knows? Maybe I'll switch to Star Wars quotes, or maybe Harry Potter. Problem is, any type of good, slick Princess Bride quote you can put on there, all you have to do is type it into Google, and there are websites about every quote that's on there. It'll bring it right up. It's hardly fair. Just free points. Why would I want to give out free points? I guess I haven't been checking to see if any of the distance guys are asking questions. I probably should do that. Okay. Troy asked about Exam 7, Question 1. I'm glad, Troy, this is the first time I'm actually seeing a question. I'm glad we explained that one a bit. Okay. Any others? We done? You feeling ready for the exam? All right. I have office hours basically now till I leave. So if you want to ask questions one-on-one, I'd be happy to talk. Okay? Again, I'm sorry, but I'm not going to be here tomorrow. So I'm glad we were able to take the time to do this today, but I won't be able to, and I don't know how available I will be on email tomorrow either because of the fact my phone's dead. Anyway, so thank you. Go away, have fun, study the exams, don't get depressed. I was teaching the last hour.
Archive recording has